We are now going to move on to using given information. So we're still labeling our diagrams and choosing a proof method, but we're going to be using given information to do that. So the first one is the one we talked about at the end of the last video. It's kind of like a preview, and it's when you're given a midpoint. So when you're given a midpoint, you should know that it's going to be in the middle of two things. So in this case, if T is the midpoint of QS, that would mean that QT and segment TS are congruent. So we would have that piece of information, and the reason is because a midpoint divides a segment into two congruent parts. But you just need to be able to label it at this point. If we are told that JN, segment JN, bisects segment ML, so be careful, you got to pay attention to which one's being cut in half. ML is the one being bisected, so we're going to want to make sure that we put MK and KL congruent. Notice I highlighted segment. If I have a segment that's being cut in half, I should be given two equal segments. So again, a segment bisector cuts a segment into two congruent segments. Now, an angle bisector is going to do the same thing, but in this case, we're focusing on the angle. So XM bisects angle ZXY. That means I'm going to have two congruent angles there because the angle is being cut in half, not the segment. Same reason a bisector cuts things in half. When you're given parallel lines, there's a few different things you want to look for. Almost always in a proof, just with the diagrams that were given usually, it's going to be alternate interior angles where you're looking for that letter Z. You can sometimes have corresponding, you can have alternate interior, all of those things, but almost always you're looking for that letter Z so that you can mark your alternate interior angles congruent. That's the one I would put on my notes. Perpendicular lines, if two lines are perpendicular, they're going to make right angles. Right angles by definition are congruent. So when we're choosing a proof method, we could either use these right angles as angles for like angle side angle, or we could use these to show that we have a right triangle because it might be one of those HL circumstances. A perpendicular bisector is going to give you two pieces of information. You have the perpendicular aspect, so you're going to get the right angles, but then you also have the bisector aspect, so a segment is being cut in half. So you can also say that you have segment TE and segment EU. So you can have angles and segments for that, and you want to label all of it. So that's how that works. So let's do a couple of these examples and choose a proof method. So we're told that XM bisects angle YXZ. So again, we're going to have two equal angles in that case. I found the vertex of angle YXZ, and that's where I knew to mark the angles congruent. I'm then told that XY is congruent to XZ. I only have two pieces of information, so I look for a shared side, which is reflexive property, or vertical angles. I see a shared side at XM. So again, if it's helpful, cover up one of the triangles and just focus on the top one. I have two sides and an angle. The angle is in between the two sides, so this would be side, angle, side. In the next example, I'm given that R is the midpoint of PT. So that means I can label two segments congruent because R is the middle. I'm then told that angle P and angle T are congruent, which is labeled, and these two angles here located at R, PRQ, and TRS. So I have two angles and a side in between. That's where I got angle, side, angle. Once your diagram is labeled, you should be getting better at determining which proof method it is. In the next example, I'm told AC bisects angle BAD. So again, it's an angle. So if I'm cutting an angle in half, I'm going to have two equal angles. They also told me that angle B and angle D are congruent. And then I'm out of given information, so I look for a shared side or vertical angles. I have a shared side. So again, focusing on one of the triangles, I have two angles and a side. The side is not in between the two angles, so this would be angle, angle, side, as opposed to angle, side, angle. In the next diagram, they tell me that I have parallel sides. AB is parallel to CD, so I'm going to look for that letter Z, and I see my alternate interior angles. Again, I knew to start with AB and DC as like the top and bottom of the Z, because those are the parallel sides. I'm also told that angle ABC and angle CDA, remember why it's so important to be able to label your angles, that they are congruent. So again, I only have two pieces of information, so I look to the picture for vertical angles or a shared side for the reflexive property, and I have a shared side. Two angles and a side, if I focus on one of the triangles, two angles and a side, the side is not located in between, therefore this is also an angle-angle side proof. The next one, HK is bisecting IL. Be careful here when you have a segment bisecting another segment. So IL is the one being bisected, so that's where you should be making your two congruent markings. H and K are congruent because we were told so, and then again we can look at the picture and say that vertical angles are congruent. If I block one triangle out, again I have two angles and a side. The side is not in between the two angles, so this is another angle-angle side proof. Moving on to number 4, I have my givens down here. I just had to move them. So segment LJ is bisecting the angle IJK. So I have an angle bisector, so I have two equal angles. These two angles are congruent, angle ILJ and angle JLK. And then I have a shared side in this circumstance. So again, I have two angles and a side, just like I did in the last one. But in this case, the side is in between the two angles. So this would be angle, side, angle. Okay, two more examples. In this problem, I'm given segments SV and segment TU are congruent. I'm also told that segment SV is parallel to segment TU. So I'm going to be looking for that Z, kind of almost like an N in this case, because it's a rotated Z, because SV and TU are those sides. So I can pick those two. I can also get the other pair out of that if I want to as well. But I'm going to go with the vertical angles in this case, just because that kind of goes with the procedure. Get one piece of information, get one piece of information, and then look. So this is an angle-angle side proof. But you could, if you went this way, you could have also gotten an angle side angle proof had you labeled your other pair of alternate interior angles congruent. Last one, Q is the midpoint of PR, so I have those two that are congruent, and then I'm also given the other two segments, so this should definitely be a side proof as you have three pairs of congruent sides. And that's how you use vocabulary words as far as given information to label your diagram.